Okay, welcome everyone. This is the Rancher Overview training. On the line you have me, Craig Jellick. I'll be doing the training and demoing today, and James Oliver will be in the chat room answering your questions. So if at any point you have any questions, he can answer them in there. If necessary, he can bubble them up to me and we can address them in the demo itself. So let's go over today's objectives really quickly. This is a technical introduction to Rancher. It's going to be very hands-on, not very many slides at all, lots of demoing. And please, if you have any questions, keep them coming. All right, once the demo is over, we'll stick around. Demo should be about an hour, but we'll stick around and answer questions as necessary at the end. So to start, just wanted to point you at a few resources. These are places where you can go for more information about Rancher or if you get stuck. First one is Docs. It's available at docs.rancher.com or rancher.com/docs. This has pretty much anything you can do in Rancher is documented here. Another great place to go is forums.rancher.com. This, you can get feedback from the community. We have a pretty active community, so if someone from Rancher can't answer your question, there's usually someone in the community that's willing and able to do so. Next, we have Slack. So, almost every open source project has a Slack channel these days. We do too. And it's a great place for just immediate feedback from either people at Rancher or, again, people in the community. You get lots of your questions answered there. So these are the key topics we're going to be going through today. I won't go over them too much right now because this is what the demo is going to focus on, but we're going to talk about setting up Rancher, access control, creating environments, attaching private registries, adding hosts, creating stacks and services, load balancers and service discovery, how you can get around using the UI, API, or CLI, a little more deeper dive into the CLI and Rancher Compose. Then we'll touch on Rancher Catalog, and finally, we'll do a little bit with Kubernetes and the other orchestrators that we have. Okay, so let's get started with the demo. Starting off here, we'll talk about setting up Rancher. So if you check out the docs, you can see the quick start guide basically gives you a good idea of what you need to start Rancher. Here is the command. It's just one simple Docker run command. If I jump to my host here, you can see that I have Rancher server running, and it's been up for about 51 minutes. And you can see there I just used the same exact command from the documentation. So the documentation, this is just sort of this quick start. It's just if you want to experiment with Rancher server. If you want to do anything more complicated or production worthy, you'll want to take a look at the different ways we have of setting it up. So for example, we talk about how you can set it up in HA mode. We talk about how you can set it up with different external databases, how you can put load balancers in front of it, all those things that you'll need to do a really production grade deployment of Rancher. With that said, let's jump to the one that I already have set up. All right, so this is Rancher server up and running. First thing we do is the splash screen asking you if we can collect some anonymous metrics that lets us learn more about our community and users. I'll uncheck it for demo purposes. One other thing I should mention, when installing Rancher, we have two tags here, Rancher server latest and Rancher server stable. So latest is what we release basically on a monthly cadence. It goes through QA. Everything is kind of fully fleshed out, but we release it and get it out to the community to see if any new bugs shake out while it's in the community. Once we feel that a particular release is stable, we basically promote it to stable, and that's what we recommend for running in production or at any large scale. So for today, I did run Rancher server latest, and that is version 169 right now. Okay, so first thing you want to do when you have a Rancher server set up is set up access control. Right now, anybody could hit this URL and access my setup. So let's jump into access control and turn it on. We have a lot of different setups here. We have different providers, GitHub, OpenLDAP, Active Directory, and yeah, you can choose any of those. For today, we'll use local, which just basically, creates and stores users locally in the cattle database. So let's create an admin user here. And enable access control. All right, so now we have access control on and our deployment is secured. One thing to note is that once you set up a particular provider, we recommend leaving it set up, and not particularly switching from one provider to the other, because if you can imagine switching from local to Active Directory, there'd be conflicts in users. So once you pick one, you sort of have to go with it. Let's talk about adding users. Now that we've turned on access control, with the local provider, we can actually add users right here. So I'll just add my colleague James as a user, generate a password for him, and we can decide whether he's a user or an admin. Basically, you want the vast majority of your users to be users, and just people who you want to be doing super user administrator things to have admin access. So we'll create him as a user. Go ahead and create, and you can see here we now have a list of users here. So let's talk about what it means to be an admin. Basically, if you're an admin, the main difference you see is this admin tab here. It gives you insight into the deployment that others don't have. So audit logs here kind of tell you what all your users are doing. Very good for conformance and auditing purposes. We already went over accounts. Processes shows you what's running in real time. This is important for debugging. If you run into a situation where something isn't deploying correctly, you want to come to the processes tab and see if there's anything stuck. At this point, we can just look at recently completed and see these processes are sort of related to the initial deployment of Rancher itself. The high availability tab is, as I mentioned in the documentation, you can set up Rancher in fully HA mode. Once you do, if you came here, you would see all of the nodes in the Rancher HA cluster here, kind of giving you an idea of how, what's connected and if they're working properly. Access control we went over, and machine drivers we will get to later. I'll just jump into settings and say, this is where you can come to sort of configure everything else about your Rancher deployment. So it's the host registration URL, which we'll touch on later. Catalogs, again, we'll touch on later, but you can configure different catalogs here. This is where we can talk about that splash screen we saw, whether or not you want to send metrics to us. And then down here, there's a bunch of advanced settings that are sort of specific to different use cases we've seen that people want to, turn on or turn off. But for the most part, you shouldn't be changing these unless there's something very specific you want to do. All right, so with that said, we can jump into creating environments. So let's go to manage environments here. So an environment is sort of the unit at which you control users. So basically, you might have a dev environment, test environment, production environment. It's sort of a failure boundary as well, and it's a security boundary too, because networks don't span environments. Our overlay network is specific to that environment, so you can't access things across environments. Other larger organizations often divide environments up by teams. So you might have a app A environment, an app B environment, that sort of thing, just coordinating with the teams in your company. So let's see, let's add an environment here and take a look at our options. So you have to pick a name, so let's call this dev1. And then you have to pick a template. And the template is basically the different parts of orchestration and framework and networking that you want to use. So the default template right now is Cattle. That uses the Cattle orchestration tool, and then a bunch of services that we need to run, our networking and just kind of make the overall experience better. Kubernetes deploys the Kubernetes stack. We completely manage that for you. If you create a Kubernetes environment, we deploy the stack inside of that environment, and we still add health check services and overlay networking for you. Mesos and Swarm and Windows are not used as much as Cattle or Kubernetes, but they're here if you have a need for that, or if you just want to experiment with these tools, they're there for you to experiment with. When you're adding an environment, you can also add the users. So we previously created James as a user. So let's go ahead and add him, and you can see here that he was added, and then my user, the admin user, is here too. When you add someone to an environment, you can select their role. There must be at least one owner. That owner sort of has, the highest level of privileges in the environment. They can create and delete the environment itself. Member is the next step down. They can deploy any types of stacks or services inside of the environment. And then below that, you have restricted and read-only. So read-only is what it seems. You can just view things. You can't create or destroy or update anything. And then restricted gives you access to creating stacks and services, but you can't access or create or destroy or update system services, which are sort of the underlying infrastructure that allows you to deploy user services. Before I go on from here, James, are there any questions that I need to answer?
Not at the moment. I'll keep you appraised.
Thanks. So actually right now, just so we can come back to it later, let's create a Kubernetes environment and create that. Okay, so now that we've created the environment, let's stick in this default environment here and go through some other things. Once you set up your environment, one thing you might want to do is set up registries. So this is particularly important if you have protected images or you're just not using public Docker Hub images. So Docker Hub is fairly self-explanatory. If you have any private registries you want to access, username and password. Same with Quay.io. Custom is just one, any of the others. In particular, Amazon ECR is a popular one. You can register that as a custom registry. If you do, the one catch with it is that you'll need to deploy the ECR credential updater. So the way that credentials work with Amazon, they expire after a number of hours. So we wrote a service, wrote a stack that basically will continue to renew your credentials so that you don't have to worry about them going bad. Okay, so now that we're through that, we can go on to more fun stuff of actually adding hosts and stacks and services. So you can't do anything until you add a host, obviously. When you click on the Add Host button, the first thing you'll be asked is the host registration URL. So this is just basically what we do when we register a host is we run a number of containers on it. The one container, the primary container, is an agent, and it connects back to Rancher. So whatever URL you put here is the URL over which it will attempt to connect back to Rancher. By default, we just figure out what URL you're hitting Rancher at, and we use that. So that works. All right, so once you get past that, you see a number of different options for adding hosts here. Probably the most popular is this custom option. Basically what that means is you're managing the creation and deletion of your hosts outside of Rancher, and you just want to run this Docker run command on the host itself, and that will launch the agent, which will then register the host with Rancher. This is particularly good for scripting or config management situations if you're using, Puppet or Ansible or something like that. Before I go over the different machine drivers, we'll copy this command and launch a few machines. Okay, so here you see that I have a couple of hosts already started. I have host Craig training node 1, node 2, and node 3 already up and running. But there's no containers running on them. All I did with these hosts is pre-pool the images that we're going to be using today. That basically speeds everything up so we don't have to wait for any downloads. So basically, all I have to do is copy and paste this command and get rid of the sudo here. I don't need it. And we're off to the races. Let's do that on the next two nodes as well.
Hey, Craig, when you get a moment, looks like we have a question regarding auth from Ananda.
Sure, let's hear it. Or I can open up and look here.
Yeah, okay. So local users added, are they per environment or can they cross boundaries? Meaning, can the same local user access multiple environments at the same time?
Good question. So they can access different environments. So basically, coming back to here, I added James to the case 1 environment. We create one environment by default, so I could add him to this environment as well. And his permissions can be set, are set on a per environment level. So he can be a member in one project and an owner in another, etc. So let's jump back to infrastructure here. As you can see, the hosts are already up and running, and the infrastructure services are deployed upon them. Before we get into that, let's just revisit this add host screen and talk about the other options you have to adding a host. So you can see across the top here, we have Amazon EC2, Azure, DigitalOcean, and Packet. These are the machine drivers that we have enabled by default. When I say machine, I'm referring to Docker machine. So basically what we do is we integrate with Docker machine so that we can basically support any Docker machine driver that's out there. So let's check out what we have as far as managing these. So if you come into this Manage Machine Drivers page, you can disable and enable them. Let's deactivate Azure and just take a look at the other options we have. DigitalOcean is enabled, and these are just all the other ones that are sort of baked into Docker Machine by default. So lots of options. But if you have your own custom infrastructure as a service, you can add it here. So basically, you can write your own Docker Machine driver, which the process is well documented, and then just basically post it somewhere where it can be downloaded. GitHub's a good place. And add it here, and we'll add it as a machine driver for you, and then you can be launching machines in your own internal cloud. So let's jump back to here, look at add host, and you can see we disabled Azure, and it's no longer there. Any questions about adding hosts or host management before I move on? Okay, just looking over my notes here, one thing I wanted to touch on as well is that you can add labels to hosts here. So if you check this out, we have edit, and this lets you just control different properties about your host. One important thing for scheduling is labels. So one we'll use later is ghost true. Save that. And we'll add ghost true to this one as well. There's some other more advanced options here. They're documented as well. We don't really need to dive too deeply into them at this point. Okay, so that's sort of what we have for adding and managing hosts. Next, we can move on to stacks and services. So you can see we have this stacks tab here. Let's just click over to all. All we see right now is the infrastructure stacks. These are, if we jump back to hosts, you'll see health check, IPsec, network services. These different blocks correspond to the stacks that are listed here. You can also dive in and see them listed this way as well. So those are our infrastructures stacks that we deploy by default when you're running a cattle environment. If we jump to user, we haven't added a stack yet, so we don't see anything here. So let's go ahead and do that. Let's call this Ghost and create it. A stack is basically just a organizational tool for your services. It's sort of the container around a set of services. You can basically do this however you want. Some people do their entire application stack from top to bottom inside of one stack. So load balancer, app. If you happen to be running your database in a container, your data layer would be there too. Other people organize their stacks by tier. So there might be a load balancer stack, an application stack, a caching stack, that sort of thing. So you can basically just decide how you want to divide up your applications here. So let's jump into adding our first service. All right. So you can see here that we have sort of a screen for entering all our information about the service. Let's scale this one up to 4. And actually, let's do it as a global service. So this will run on every host. And let's call this Ghost. Change the image to Ghost. And then down below here, you can see we have all kinds of different options here. You can add volumes. You configure networking. By default, you're going to get the Rancher overlay network. These are all sort of lower level things around security. All of these map to Docker parameters, so things that you can do when you do Docker run, you'll see here, they kind of map pretty directly. Rancher secrets, so this is to kind of get sensitive information like access keys, secret keys into your container. You can do that through here. Health checks, we'll talk more about health checks later, but you can configure a health check to make sure your service is up and running. And you can add labels to your stack. So you can say, this is my Ghost app. Actually, let's do it this way. The app is Ghost. And then finally, you can add scheduling constraints. So if you recall earlier, I added the Ghost label to 2 hosts. We can add that here. We can configure scheduling to respect that here, rather. So the host must have a host label of Ghost. And what are our potential values? True. So this means even though this service is a global service that should run on every host, it will be constrained to every host that has this label. Let's go ahead and create it. Great. So go, and then if we jump over to the host screen, you can see that one instance of the service ran on this host and one instance ran on this host. Now, if we jump back here, we can see the user stack hosts, and let's see here. Let's actually upgrade this. So one thing I forgot to do was expose a port for this particular service. I forget the Ghost port offhand, so let's find out what port it's listening on by default. Oh, looks like I'm not going to find it. That's okay, not terribly important. This is just if I exposed a port, then we'd be able to actually access that service. Let's switch over to, let's add a Nginx one, because because I know the port for that. So we can say 88 and maps to port 80 of the container. Let's run this on every host, and let's create it. So now it's activating an Nginx service, and this might just take a minute, right? So I didn't pre-pull the Nginx image, so it's just taking a minute to pull it before it gets it up and running. Back here, you can actually see this is a hyperlink to the actual service itself, so we can click on it, and you can see Nginx is up and running and being exposed on port 88 of the host. Great. So let's delete this one. And there we are. Before I move on, do we have any questions? Okay. So let's talk a little bit now about load balancers and service discovery. So if we jump back to, actually, let's add a new stack. That is my app one. Let's start by adding a service. And let's again tell it to run on every host. And we'll say Nginx. Launch it. This time we're not going to expose a port at all. And let's launch it. So let's jump back to the host view. I kind of tend to go towards the host view a lot because it gives me a nice overview of what's going on. So you can see the stack app one was deployed and it has an Nginx container running on every host. Just jumping back to our stack again, let's now add a load balancer in front of this. There's actually no way to get to this service publicly now because it's not exposed. But we can add a load balancer to the stack and expose it. We'll just run one load balancer. You can actually deploy load balancers, as many of them as you want. You can deploy them globally. One common pattern is to deploy the load balancers globally and then put another tool in front of those load balancers to balance between them. Some people use round-robin DNS. Some people will use an external load balancer like ELB to basically give you that fully HA model. And just give me 1 second.
Hey Craig, we have a question regarding the load balancer. Andreas says, do you recommend to add a load balancer for every project or create a global load balancer for all projects?
So I think that just depends sort of on how you want to organize things. When you deploy the load balancer, we're deploying a container that's running HA proxy inside of it. It's certainly capable of handling more than one service. It's very common configuration to have a single load balancer service balancing for many services. But if you want to have sort of that fully self-contained feel where the load balancer is part of your application stack, then you would just stick with sort of a 1-to-1 ratio. So it sort of just depends on how you want to manage and organize your apps.
Thanks. And one more. Chris Reed mentions, when you clicked the 88 hyperlink, which host did you hit? Random?
Right. So that was random. Yes. Basically, there was a number of different hosts that were exposing that, and that's sort of where you need the next level in front of a load balancer to balance between them to sort of get the full HA mode. So another simple thing is, just in your DNS, say this was at myapp.com, you could have multiple A records pointing to all of your hosts. And then that would just round robin between those, which would be hitting a load balancer, which in turn is spreading the traffic between all of your services. So let's choose Nginx here and port 80, going to port 80. And yeah, so this will be our rule. Basically what we're saying is just configuring the rule, that is how it's going to be inside of HA proxy, but we're exposing it on port 80 and we're sending it to the Nginx service, and we're talking to the internal port of port 80 on the Nginx service. There's some advanced configuration you can do below. You can even go as far as pasting in a custom HA proxy config, and then just like every other service, you can control how it's deployed using labels and scheduling. You can also do SSL configuration here. I think you might have to set up certs in another section to do that. So I'm going to leave this as running on just a single host and click create. And again, I'd like to jump over here. You can see here. So you can see, I'm sorry, I'm looking for where the load balancer app was deployed. Oh, we can see here, let's drive into it this way. Yeah, you can see here that the image deployed was load balancer HA proxy, and we can access it if we go back to here, click on this. We're now hitting HA proxy, which is balancing to all of the Nginx services that I had deployed. One other thing that I think we should talk about now before moving on is health checks. So let's look at this ghost service here. Actually, you know what would be a better one is the Nginx service. So just diving a little more into health checks. What health checks do is you configure an endpoint on your container. It doesn't have to be exposed publicly on the host, but you configure an endpoint where we can periodically hit it to ensure that it's healthy. So for Nginx, the port that it's listening on by default is 80. If we just go to /, you have to have a request URL as well. So / is what Nginx has by default. And then you can configure your timeout for initialization. That's how long it takes for the container to start. Reinitialization is if the container is restarted. How often you want us to check. How many milliseconds before the check should give up. And then how many checks it takes to determine it's healthy and how many checks it takes to determine it's unhealthy. Based on all these parameters, we'll take the below action. So we either do nothing, which just means we'll mark the container or the service as red in the UI, or we'll recreate it. We'll destroy the container, create it. It'll go through our scheduler. It'll either get created on the same host or on a new host, depending on normal scheduling rules. Or you can do this last one, which is sort of a quorum-based recreate. So if you don't ever want your service to go down to 0 instances, you can choose the last option. I'll just say recreate. So by changing that, we're seeing it had to upgrade the entire service and is at this point reconfiguring it. We should see it go to healthy pretty quickly here. Let's check on it in the host view. Cool. All right, so you can see it's upgraded, and then we just have to click the finish upgrade button, and the red containers over here were the old version. So finish upgrade basically deleted the old version, and the new version is up and running with health check listening. All right, any questions, James?
Yes, we've got one, and I know there's a good answer for it. Norman Schlater says, I have 10 external IPv4 IPs per physical host. let's say I would like to deploy 10 OpenVPN containers. Would it be possible to map these IPs to the different OpenVPN containers?
Yes. So there's sort of a couple options you have, but the first, and I think maybe the most interesting, is in here you can configure the IP addresses that your host has. So it's kind of error-prone for us to try to discover these correctly programmatically. So we basically just give you the option to configure them directly here. So you can add your 4 IP addresses here, and then what we will do is we will recognize that that host has IP configured on it, and we will basically schedule based on those IPs. So if you say, I want to deploy a service that, let's go to deploying a service so I can illustrate this a little bit better. So basically at this point, when you're deploying it, if you say I want host port 22, that maps to 22, if we know that there are hosts with IPs configured on them, basically if we deploy to that host, we'll pick one of the 4 IP addresses, and that's what this port 22 will be bound to. Now, if you want it to be bound to all 4, you can explicitly put in 0000, and that will force us to bind to all 4 IP addresses. If you don't care about the scheduling aspect of this, and all you want to do is just forcefully deploy a particular service to a particular IP address, you can always just add the IP address here, and basically that doesn't impact scheduling. It's just when the container is deployed to the host, this is the IP we'll use to expose the port. Any other questions? Okay, so let's move on to other ways you can access Rancher. So everything we've done so far has just been purely UI driven, but have other options. One great option is the API. So we have a tab here that shows you the endpoints for the API. We have V2 beta. It's been in beta for a long time. Basically, you're taking the Gmail approach of keeping it in beta for a long time, but it's a very stable API. That's the one. Everything we've done in the UI interacts with the API. Everything goes through the API, and it goes through the V2 beta endpoint. So we can actually jump into that from here. And this is the API. This is a great tool because basically what we did was we took the raw REST JSON API and we added this little wrapper script around it to present it very nicely in a browser. At this level, we're looking at sort of things globally. We're not scoped to a particular environment. If we come back here, we can jump into our current environment scoped API endpoint. Let's do that. So you can see it added /project/1A5. And we can click through and look at some of the things we've created here. So let's look at stacks. You can see here we have all the stacks that we deployed. This includes the infrastructure stacks, but it also includes the ones we created ourselves. So let's actually jump into this one here. Let's go down one more, find a user-created stack. There we go. So as you can see, everything is sort of discoverable via links. So now that we're in the stack, we can see everything that that stack is associated with. We can jump to its account. We can see what host it's deployed on. Excuse me. We can see the instances. We can see the services it has. So I just clicked into services, which gives me a link to a list of the services that are part of this stack. And yeah, we see the Ghost service and we see the load balancer service. Great. Excuse me. I'll take a drink of water real quick. And I'll just go one level deeper. We're now in the service, and the other interesting thing here is these actions. So these actions are things you can do to the service, and it's whatever falls outside of the normal create, update, delete range that you have from the post, put, and delete HTTP methods. So these things are sort of like very specific actions you want to take, like upgrade. Again, this is what the UI uses. If you wanted to upgrade this stack, you would be interacting directly with what you see here. And the API UI, which is what we call this, even lets you click on a button to do this. And when you do it, we also give you the curl commands or the raw HTTP request. So if you're building scripts around Rancher, this is a great tool for figuring out, those curl commands or those HTTP requests that you need to create. All right. So the last important piece of this is keys, which I didn't touch on. When you're entering through the UI, you log in with your username and password. Excuse me. You're logging in with your username and password, but if you want to interact with the API directly, you create account keys. So create them here. You see them right here, and these are what you would use if you're making the curl command. This would be the basically basic auth you would put in for username and password. Or if you're using the CLI, which we'll do shortly, you would use these. So let's just jump into using the CLI really quickly. Actually, before I do that, any new questions?
No, you're all good.
Great, thank you. All right, so let's cd into the CLI directory. Oh, I forgot to mention. So actually, I'll have to close this. We'll just create new ones. Basically, you only have access to copying those keys once. So if you click off that screen, you're going to have to create new keys. That's a security measure. We don't store them in such a way that we can give them to you more than once. So to get to the CLI, bottom right here, you have different download options. We have the CLI and then its predecessor, Rancher Compose. So Rancher Compose, while we still use compose files and compose syntax, Rancher Compose here refers to the binary that you would use to launch those compose files. And it, of course, is heavily inspired by Docker Compose. But we have since sort of replaced that with the Rancher CLI, and that's where we're adding all new functionality. It sort of combines the best parts of what you would get from Rancher Compose, plus all the things you want to be able to do in the UI that aren't specific to compose files, like listing containers, listing services, all those things. So you're 99% of the time, if you're new to Rancher, you're going to want to use the Rancher CLI. This is just the download, which is what you see here. The Rancher endpoint here, this is the CLI that I downloaded previously. So the first thing you want to do is configure Rancher. So here's the config command. And it's picking up what I had previously configured. So we're going to override that now with new inputs. Actually, I don't think we need the schema. And then let's generate keys. All right, so it used those keys, which are account level keys, to query the Rancher API to see which environments I have access to, and now it's asking which one I want to be the default environment. So, all right, and then it saves it off to a file stored in your home directory, and now we can get started using the CLI. So by default, Rancher PS is showing all the services that we've deployed. Let's see what other options we have under PS. So that just showed user services, the Ghost and the app, and the load balancer. But if we wanted to see system services as well, we can do that by adding F. And you can see all the system services that were previously deployed. And then finally, you can change it up to look at a container level. So these are all the containers that are deployed in our environment. Let's do this again to take a look at all the different commands. You can perform operations on catalog. We've already configured. You can basically get a proxy to the Docker socket and interact with it directly. You can do things with environments. You can exec into containers. You can list hosts. You can get the logs and tail the logs, just like Docker logs -f. And you can do just a number of different things. For example, we can do Rancher hosts. And we see a list of hosts there. And then finally, probably one of the more interesting ones is Rancher Up. So Rancher Up will actually launch a stack based off of the Docker Compose and Rancher Compose files you have in your current directory. Sorry, I wanted to show you the additional options for Rancher Up. And you have a ton of flags you can add here to control what you're doing. So let's do a up command using Rancher. So one really nice thing about the UI is that even though we added the UI, you can now view their compose files. So these are the Docker Compose files and Rancher Compose files. So basically, we reverse engineered the things you did directly with the API to create these compose files that you can now launch via the CLI. Just to make sure I didn't mess anything up, I previously copied those. So we can look at them now really quickly. And I just changed the port earlier too. But these you can see are a couple of services, a load balancer service and a app service. Actually use a different image here. But let's use Rancher Up. So you can see we get logs here. It's telling us what it's doing. It's creating the stack CLI, creating the app, creating the load balancer. We jump into the UI. We can sort of dynamically see it being created and the app being deployed. And once the load balancer is healthy, we'll be good to go. Great. So we have our new CLI-based application up and running. Again, this is a great tool for scripting. So it's really popular with our users. Any questions before we move on? Okay. So the next thing I want to talk about is the catalog. Yes. So we have the catalog here, and basically these stacks that we've been creating, you see there's config files that are generated, Docker Compose, Rancher Compose. The catalog is basically a way to reuse those. So we have two catalogs that are included by default, our library and the community catalog. If we go down there, all those system stacks you saw us deploy are here. This is where they live. So we have Rancher IPsec, Rancher EBS. Storage is a storage stack, and just all the different things that we deployed, they're all stored here. The community catalog is just what it sounds like. We basically have an open source catalog where different common applications, users can develop compose templates for them and submit them to our community catalog so that other people can get the benefit of them. So let's deploy one just to get a feel for it. Elasticsearch is a good one because it's somewhat complicated. By that I mean, if we look at its compose file, we have 1, 2, 3, 4, 5 different services, 6 different services, 7, 8 different services that are deployed when you deploy this catalog item. It has some additional configuration here, and basically one interesting thing is you can write a catalog and you can configure questions for it to allow users to customize it in the UI. So you can see here, unique name to assign to your Elasticsearch cluster. That is what we see here. And yeah, it's as simple as that. One last thing I'm going to do is I'm going to explicitly choose to deploy an old version of this catalog item so that we can see how we can upgrade it.
While that's launching, Craig, we have a question from Ananda regarding machine drivers. It says, for the VMware vSphere machine driver, do you connect to vCenter Server, the management software, or connect to host itself running VMware ESXi hypervisor?
So that is a implementation detail of how it was written in Docker Machine, but I'm pretty sure it interacts with the management server, specifically to launch the VM and everything. And then basically the way Docker Machine works is it interacts with whatever the management API is. And then in the end, it wants to get SSH access to the VM. So it basically provisions a key that lets it access it via SSH, and then it uses SSH commands to do the things like setting up Docker and whatever other customizations you told it to.
Thanks. And one more regarding the screen showing the YAML for the Elasticsearch cluster. Chris Reed asks, did that YAML just generate the stack, or the actual services containers in the stack as well?
Did that YAML generate the stack? Oh, so basically, hopefully I answered this correctly. That YAML is what deploys everything. So we have a microservice called Rancher Compose Executor that basically will read in any Docker/Rancher Compose YAML files, and it'll generate the API commands for actually creating services that correspond to whatever's in the YAML file. So basically what happens here when we're looking at that big long YAML, when I clicked create, it talked to our Rancher Compose Executor microservice, which in turn issued a bunch of API commands to create a stack and create services inside the stack based off of that YAML file. Do you think that answered it, James?
I think so, yeah.
Okay. Let me know if it didn't. All right. So here, sorry. So here we see that we've deployed the Elasticsearch stack, and we also see that an upgrade is available. So let's just make sure we're seeing everything we can about it. Yeah, in the user stacks here, we make it very prominent when there's an upgrade available, so that you as a user know, oh, so new version of my application is in the catalog. I can deploy it now, and then we make it pretty easy to upgrade too. All right. So here, basically, we take you back to the screen where you answer the questions about it. It's already selected the newer version for you, and we can click upgrade. And then it will iterate through all the services here and deploy the new versions of each of these services. So while that is going, let's jump into our Kubernetes environment real quick. So we created this Kubernetes environment, and then we kind of just left it alone. It is waiting for hosts to be added. Let's add some hosts really quickly. So I'm going to copy this command. Once again, I've pre-created hosts with images pulled, so I'm going to copy this command and launch on those hosts. All right, so we have nothing deployed here. Get rid of sudo. And he will fire off 3 Kubernetes hosts. My other two hosts may have, let's see here.
When you've got a moment, we've got a quick question about Kubernetes.
Okay, so I think basically I did something wrong with these two hosts where they're not configured correctly anymore. They lost internet connectivity or something. Excuse me. So, but let's just check on what's happening in the environment anyway. And show system containers. And you can see the Kubernetes stack is being deployed as we speak. Wanted to have 3 hosts to show sort of deploying in HA mode, but I think we will be able to live with a single host. Go ahead with the question, James.
Yes, Parth Gandhi asks, when we create a Kubernetes environment, the Grafana dashboard is installed on one of the hosts along with InfluxDB. How do we access this dashboard? The URL that we get using kubectl cluster info does not work.
James, would you happen to know the answer to that one?
I think we use the Rancher router to access it, but I can't recall exactly where we display the link. It would be similar to how you access the Kubernetes dashboard once it has deployed, that is.
So yeah, I will have to, we have a dedicated Kubernetes training very similar to this one, but it's a much deeper dive into Kubernetes that you might be able to get a better answer for in that training. Or, as I mentioned earlier, you can get pretty quick answers to questions in our Slack channel. There's a dedicated Kubernetes channel inside of there, so you could hop onto the Rancher Kubernetes channel and ask that question and get a pretty quick answer. Sorry, I don't have an answer offhand for you. Let's just go back and see if, kind of waiting for everything to get up and running. Looks like the add-on starter is. Yeah, so might not be fully up and running yet. We'll jump back to this environment and revisit. Okay, the Elasticsearch upgrade is complete. You can see here it's waiting for us to finish the upgrade. And just to reiterate what that means is basically you see double containers for all of these right now because the old ones are still there, but they're stopped. So basically we don't delete them until you tell us to. Because we also give you the option to roll back, which would, instead of deleting the old ones, it deletes the new ones and restarts the old ones. But let's just finish that now. And jump back here, you see all those red stopped containers are gone, and Elasticsearch is fully upgraded. Okay, any other questions, James, before I move on?
One moment, just looking. Oh, we've got a question about Kafka. Gary Collins asks, Kafka community supported experimental. What would be the recommended way to deploy Kafka to a Rancher managed environment? Or is it better to keep Kafka external from Rancher? And I think I think I can go ahead.
Excuse me, go ahead.
Yeah, so there you have a variety of options for launching Kafka. I would recommend personally use Kubernetes. There is an open source Helm chart for deploying a distributed Kafka cluster, and it is known to be stable. However, you need to consider who's going to be publishing and subscribing to your Kafka cluster, because there's added complexity when you're attempting to consume it outside of the Kubernetes cluster. And this issue exists with any orchestration platform deploying within an overlay network.
Great, thanks, James. So we sort of hit our 1 hour. The one last thing that I wanted to just do really quickly is talk about storage. So we have a number of different Rancher storage drivers. These end up being basically Docker volume plugins, so that if you need persistent storage, you can deploy one of these, and then your containers can basically use volumes that are backed by that are backed by, persistent storage. I should have done it this way. There's sort of third-party ones like NetApp, but then there's ones that we've written ourselves like Rancher EBS and Rancher NFS. Really quickly, we can just talk about the Rancher NFS server. Earlier today, I set up a NFS driver. Let me see here. So I'm going to pause my screen share. James, let me know if basically you can't see my screen change.
Will do.
Can you see my screen change?
Nope.
Okay, great. So I'm going to configure the NFS driver now. It's just publicly exposed NFS, so I didn't want to share that. All right, so grab the IP address. Okay, can you see my UI?
Yep.
Okay, great. So I just deployed the NFS driver. One thing now, we can go to storage and we can see that it shows up as a storage driver, and then we can actually use it. So let's quickly deploy a service that will use it, and we'll just add it to an existing stack. So run one.
So I've got a quick question about NFS. Andreas asks, what's the difference of NFS in the catalog and in the environment configuration?
NFS in the, so those are, let me finish this thought here, test one, and then Rancher NFS. Okay. So while I'm going to launch this and then answer your question. So basically, I'm just launching a standard Ubuntu image, but I've added a NFS-backed volume to it, and I'm launching it on each host. So I think what you're talking about is when you go to manage environments, and if you wanted to configure, say we wanted to configure cattle, yeah. So basically, you see all of the templates, all of the library template items that are in the library catalog. So if you wanted to have every single cattle environment that you deploy have access to NFS, you could add it to your environment here. And you'd have to add the configuration and everything. That's generally because you might have different NFS servers per environment or per user. You might not want to do it that way. It only shows up here because we basically show everything here that is in the library catalog. James, do you think that answered what they were asking?
Yeah, I think so.
Okay, great. So let's look to see if, okay, great, that NFS test service is deployed. And let's hide the system containers, make it a little bit easier. We can see it deployed to each of the hosts. Let's just get a shell and see what we have here. That directory I created was test1. There's nothing in it, so we can just touch test1 foo ls test1. So there's the foo file, and then if we jump over to another host container of the service running on a different host and look at test1, we can see that the foo file is there. So with NFS, you can have a basically shared storage across all instances of your containers running on all their hosts. All right, let's jump over to last thing here is we'll just check on our Kubernetes environment, see if the UI is deploying. Yeah, so you can see here we just kind of pop you out to the default Kubernetes dashboard. But we also, just right in the UI, we give you access to kubectl here. So you could do cube system. Cool. So basically that -n means namespace, and cube system is sort of like the equivalent to the infrastructure services I've been talking about, scheduler, networking, that sort of thing. They have their own set of infrastructure services, and they put them in the cube system namespace. So that was just to show you, you know, once it's up and running, you can have direct access to Kubernetes. You can also generate a config and then, you know, be off to the races with your local kube control CLI and deploying things that way as well. And anything else interesting here? Yeah, so thing here is just, you know, we see some services that are Rancher specific for the networking, and then basically everything that is tied to the Kubernetes control plane. All right, that covers just about everything that I had on my list to cover. Do we have any more questions from the audience?
There's one general question with extra Kubernetes questions. Which Slack channel can customers interface with us?
So if you sign up for rancher.slack.com, there will be like a general channel, and then there'll be a channel called Kubernetes. That would be where, you know, open source users can go to answer questions. But the question specifically for customers that want to ask private questions, I think we have contact information on rancher.com on how you can sort of get in contact with us over private channels.
Thanks.
Any other questions?